So we have self-check 1.4, it's part 2. It says aluminium reacts with bromine to form the aluminium bromide as shown by the equation. 2 moles of aluminium reacts with 3 moles of bromine to produce 2 moles of aluminium bromide. If 15.8 grams of aluminium and 55.6 grams of bromine are available for the reaction, then determine A. the limiting reactant, B. the mass of aluminium bromide produced. So अब इस क्वेश्चन में हमें क्या गिवन है, दोनों रिएक्टेंट्स के masses गिवन है 15.8 ग्राम and 55.6 grams, and we are asked to find out the limiting reactant between these two reactants. So limiting reactant is always the reactant part, and in part B we have to calculate the mass of aluminium bromide produced, that is mass of this desired quantity or product. So let us write the mass of aluminium. Mass of aluminium is 15.8 grams. So after writing the mass, we have to follow a procedure which says that if you are given mass of a given quantity, for example aluminium and bromine in this case, we are going to convert them into moles of the given quantity. So now we are going to convert the mass of aluminium and mass of bromine into moles. So for mass of aluminium, the atomic mass of aluminium is 27 gram per mole. Now we are going to calculate the number of moles by applying the formula mass by molar mass. Mass is 15.8 gram as given by the question. 27 gram per mole is the atomic mass of aluminium, and the answer is 0.568 moles of the aluminium. Now similarly we are going to calculate the moles for the bromine. Write the mass of bromine as given in the question statement. It is 55.6 grams. Now the molar mass of the bromine is 79.9. It is the mass of one bromine, and here as you can see it is a molecule, so the molar mass into 2 comes out to be 159.8 grams per mole. Now we are going to calculate the number of moles of bromine, and it is given by the formula mass by molar mass. Mass is 55.6 grams, molar mass is 159.8 grams, so you will get the answer 0.348 moles. Now we have calculated moles of the given quantities from their masses. Now in the second step, what we are going to do is that we are going to convert the moles of a given quantity, that is aluminium and bromine, into moles of desired quantity, and our desired quantity is aluminium bromide, AlBr3. So now let us look at the equation. According to equation, the equation was given in the question. This was the equation. As you can see, the 2 moles of aluminium and 2 moles of AlBr3. So now we are going to compare the moles of aluminium with aluminium bromide, and then we are going to compare the moles of bromine with the aluminium bromide in order to find out the limiting reactant. So in the first case, we are going to compare the moles of aluminium with aluminium bromide. It is AlBr3. So moles of aluminium bromide, we are going to calculate it by using a formula which says that if you have a desired quantity, if you want to find out the desired quantity, we are going to obtain it by multiplying the given quantity into conversion factor. So the given quantity in this case, 0.568 moles, these are obtained from the moles of aluminium. So you are going to multiply these moles of aluminium with the conversion factor. So what is the conversion factor? Conversion factor is coefficient of desired quantity by coefficient of given quantity. So our desired quantity is aluminium bromide, and the coefficient of aluminium bromide, as you can see over here, it is 2, and the coefficient of given quantity is 2. So we will get the moles of aluminium bromide, that is 0.568 moles from the aluminium. So now we are going to find out the moles for the bromine. We are going to find out the moles of aluminium bromide obtained from the bromine by comparing the moles of bromine with the aluminium bromide. We are going to compare them by using the equation. So here as you can see, equation it says 3Br2 and 2AlBr3. So 3Br2 and 2AlBr3. Moles of aluminium bromide, we are going to calculate it by using the formula which says that if we have a desired quantity, we are going to calculate it by multiplying the given quantity into conversion factor. So given quantity is the moles of bromine, and we calculated the moles of bromine over here, which came out to be 0.348 moles. So this is our given quantity, and we are going to write it over here 0.348, and now we are going to multiply it with the conversion factor. So the conversion factor is coefficient of desired quantity, as you can see over here, coefficient of desired quantity. What is the coefficient of desired quantity? 2 for the aluminium bromide, divided by coefficient of given quantity. So given quantity coefficient is 3, so you will get the answer 0.232 moles. So now we have 2 moles, one obtained from the bromine and another obtained from the aluminium. So the aluminium moles are 0.568, while the moles for the bromine are 0.232 moles. So as you can clearly see that moles of bromine, they are far less as compared to moles of aluminium. So we can say that our limiting reactant is bromine. So we have concluded that the limiting reactant is bromine. So now our first part, or part A of the question, is complete. Moving on to the second part, to calculate the mass of zinc sulfide. So mass of zinc sulfide can be calculated by applying the formula. And before applying the formula, we are going to calculate the molar mass of aluminium bromide, which is 27 for aluminium, 79.9 for bromine, and as you can see there are 3 bromine atoms, so multiplying it with 3 we will get the answer 266.7 grams per mole. Now number of moles, as we have already calculated over here, these are 0.232 moles of aluminium bromide. Now mass of aluminium bromide, here is the formula, number of moles into molar mass. So number of moles 0.232 into molar mass 266.7, we will get the grams of aluminium bromide, which are 61.87.